Hello, let's place dominoes. It's time to solve pips. Let's try the easy puzzle first, as always. All right, we need three of a kind down there. What suffices for that? Ones, it looks like. One with connected to a less than 5, which could be a 4 or a 3. We also need an 8, which could be a 1 and a 5 and a 3. And then we'll put the 1, 4. Oh wait, no, sorry, we can't do that. Sorry, because we need the 1 down there. So we need the 1 and a 4 matches the 4. Sorry, that's what we need. And then 1 and 5 goes here, 1 and 3 goes here. And there we go. That was the easy puzzle. Okay. We'll try the medium puzzle. Let's go. Okay, we need to... Oh, this is interesting. I'm going to add these up, actually. So these all together make 28. So we need 28 pips represented, and then the remainder go down there. So how many do we actually have in the dominoes themselves? We have 4, 9, 17, 24, 35. Okay, so I think that means we need 7 pips not accounted for up top. Is that useful? I don't know if it's useful. Like, you know, but by that I mean, for instance, we could put a sort of, if we put a 5 here, that means we would need a 2 to be down here. I mean, this isn't going to work because the 6 will break the 7. So we sort of, I guess that's, you know, that we have ruled out immediately, for instance. I don't know if this kind of thing is helpful for me in this context. Doesn't seem like it's very helpful. It just rules out a couple of things. Assuming I did that arithmetic correctly. Hopefully I did. Anyway, okay, so how do I actually get about solving this? Well, we can't put a 4 into the 8 because we don't have another 4. If we put a 6 here, we'd need a 1 down here, I think. No, wait, we need a 1? Now I already can't even remember what the number was anymore. I think it was a 7, right? That we add up to. So if we put that there, we'd need a 6 going out here, which I don't think could be this one because then we wouldn't have enough to make the 13. So we could put this here. Then we'd need 8 in this to fill the 13 in total, which we actually can't make. So this isn't possible either. What about this? And then a 3. Then we'd need 2 6s in the 13. And we'd need a 1 pointing up into the 7, which couldn't be the 1 6 because we need that for the 13. So it could be the 1 4. Oh, this will work. Because 7 can be 4 2 1. And then this will be this way. Yeah, okay. I don't really know how I should have solved that, but I kind of combined a few different approaches, I guess, and got to the answer, but it wasn't very elegant or smooth solve. But was my calculation correct? It was, yeah. There were 7 down there, so that was helpful, honestly. Okay, let's try the hard one. Let's see. We need 4 of something. What could that be? It could be a 4, could be a 3. I think those are the only possibilities, 4s and 3s. And how do I start with this one? People occasionally say I should just start trying things, putting them in instead of trying to solve it in my head. Let me know in the comments what you prefer. I mean, there's something in my brain that says, no, you shouldn't just guess. You should try and figure it out logically. But some people don't seem to, you know, they think, well, it would be more efficient if you just tried something. So I don't know. Let me know how you feel about that. Oh, also, the 4 region needs a double. So what did I say the 2 possibilities were? threes and fours. Oh, we do have double three and double four. Those would both work. Okay. How could we make the 8? It can't be a double 4 inside the 8 because that would block off the greater than 2. I mean, it could still be a 4 going in other, we could still have a double 4 in theory if we had I guess that's, I mean, we know we need the two 8s being bridged in some way. So this wouldn't work because then this 8 would need a total of 4, which we don't have. So that's something, I guess. It's not very much, though. Less than 6, less than 7. So the less than 6 also connects to the less than 7, but then the other half of the less than 7 goes into an empty cell, which could be anything. That means the double in the equivalent region goes either this way or this way. None of these things feel very helpful. The 9 also has, a single, one single domino contained within it. It must. It's either here or here. That again doesn't feel very constraining because, well, actually, I guess there aren't very many things it could be. It can't be the 6-3. It could be the 4-3. It could be the 2-3. Could be the 3-3. Okay. Could be the 4-0. So never mind. There are a fair number of options. It could be the 5-2. But it couldn't be, I mean, yeah, just a few things it couldn't be. It couldn't be the 6-3. Couldn't be the 4-4. Couldn't be the 5-3 because we'd need ones for those. We need a 1 for those to finish it off. And 6-3 would break it immediately. 5-4 would break it immediately. Doesn't feel very all that useful. Yeah, I don't know. Okay. Maybe I should just try some things. Should I just try some things and see what happens? I don't know. I don't really know where to begin with this. Oh, this already breaks immediately. What about this? That breaks immediately as well. So this can't be 3-6. I mean, that's really not saying very much. Could it be this? This feels like a terrible way to approach this. 5 goes into the 4. That doesn't work either. This would need a 6 down here. Maybe the way to think about it is what we can put in the 8. Maybe we start with that. What double can we put in the 8? Let's think about it that way. If we put 7 in here, we'd need 1, which we can't do. If we put 5 in here, we'd need 3. Can we do that? Then would be a few options because we could put double 3 going up here, and then we could put a 5 going into greater than 2. That's fine. This is immediately fine. So that one works. 4, we could put a 4, 5, 3. That works as well. Okay. This is not very constrained. We can't put the 5-4 in there because that breaks it. If we put the double 3, we'd need a 2. That's fine. Oops. That works fine, completely fine. So the 4-0 and the 3-3 work fine. The 2-3 works fine, I think. 5-2 doesn't work. 4-4 doesn't work. 5-3 doesn't work. I mean, we don't have a huge number of options. So this could be a total of 4, a total of 5, or a total of 6, which means this lower right half is 4, 3, or 2. I mean, that's just not very constrained. 4, 3, or 2, which means this top cell is, well, I don't know. I guess it depends what we put in there. Yeah, I don't know. That doesn't feel very helpful to me. It doesn't feel very helpful. I really don't know how to think about this. Maybe I start with the equivalence region. Could this be 3s? I mean, why not? Oh, this can't go here. It would have to go here or here, for whatever that's worth. And this all feels like just anything could be anything. Actually, in this particular configuration, I don't think I can complete the 8. Oh no, maybe I could. Yeah, I could. Never mind. Yeah, this all feels fine. Well, now I can't complete the less than 7. Or can I? No, I can. No, I can't. Because I don't have enough 3s. Maybe I need more 3s. Maybe that's the thing. Maybe up here needs to be 4s. I mean, this feels so grasping. I really don't like solving this way, but I just have not figured out how to attack this puzzle otherwise. I don't really know how to tackle this. It just feels so unconstrained for the most part. Oh, I guess I never thought about the fact that the 8 could be made up of a 5, 3, and a 0. Is that useful? Just to try that. Then we'd need a 4 going to, I mean, I don't know. It still feels like this could be anything. Then we'd need 3s back up in the equivalence region if that were the case. And similarly, if we made the equals out of 4s, we could put, I mean, again, I don't know if this is like doing anything useful, but then we could make the 9 out of a 6, 3. This feels so random in terms of my solving of it. What difference does this make to anything? I don't know. I'm just putting whatever anywhere. This doesn't feel like anything. No, I need a 4 for up top. I can't do that. I mean, was that... I feel there must have been other possibilities to complete this. I don't understand how this one's meant to be solved, other than just trying things, which doesn't feel very satisfying to me. I don't know. Let me know. Let me know. Please let me know. Because I really don't get this one. Yeah, I just sort of tried stuff and eventually it worked. That was about it. All right. Those were the pips. Back tomorrow. Bye for now.